Assalamualaikum warahmatullahi wabarakatuh, and a very good day. So we are from class A4CS1121B, and here is the group members. The first one is Vivian Natasha binti Hashim, while in the middle is Aida Nafisa binti Muhammad Firli, and the last one is Nur Shamimi binti Muhammad Fuzal. In this video, we are going to look at the four parts.
I am Aida, and I will be explaining about the introduction to related rates and also the problem statement. For the first one is what is related rates. Related rates problem is an issue involving at least two changing quantities and asks us to find the rates of which one quantity is changing. We use related rates to find any rates when the other rate is changing. Next, what is the difference between dy over dx and dy over dt? dy over dx is used in a normal differentiation where the value of y will change when x changes, meaning x is the independent variable that will affect the value of y, the dependent variable. But in related rates, dx is changed to dt, where dt is the changes with respect to time. For example, we use dv over dt when we want to find the changes in volume with respect to time, dA over dt when we want to find changes in area with respect to time, and dr over dt when we want to find changes in radius with respect to time. Moreover, in related rates, dt can be changed to dr, dA or dh. For example, if the question wants us to find the changes in area with respect to the radius, then we have to use dA over dr. And if the questions want us to find the changes in the volume with respect to the area, then we have to use dV over dA. And note that in related rates also, our rates can be either in positive or negative. If there are words like flowing out of the container or dropping out from the container in the questions, then we have to know that our rates is in negative, or otherwise our rates will stay in positive. That's all. Thank you.
Alright, so to illustrate the introduction of related rates that is presented by Aida earlier, let's take a look at this example. Okay, however, before you answer the question, you must read and understand what the question really wants. Alright, meaning that you have to pay a lot of attention to avoid from being careless. So here is the first one. A conical water tank filled with water has a radius of rcm at the top and hcm height as shown in the figure 1. At the left, you will see a figure 1. You will see a conical water tank with its height and the radius. So what the question really wants is, the question wants you to show that the volume of the cone is equals to 2 over 3 pi r cubed when the height of water is twice the radius. So this information needs to be highlighted, okay? Okay, so meaning that by the end of your answer, the volume of the cone that you will get must be equal to this one, to this volume, which is 2 over 3 pi r cubed. So what is the first step in order for you to complete this question is you have to write down the formula. So based on this question, this is a conical water tank, right? Meaning that you will have to write down a cone formula. So here is the cone formula, which is 1 over 3 pi r squared h. Okay, so I will show you the whole solution first. So here is the solution, okay? So why do we have to substitute h into 2r? Okay, from the above information, we have to rewrite the volume of the cone into a single variable. So meaning that we substitute h, we must substitute h and make it related to r. So why is that? Because in here, you'll see that there is no variable h, right? Meaning that the h will be substituted into something that is related to r. So how do we know that the 2r is equal to h? This is because from this information, we know that h is equal to 2r. Hence why we substitute h into 2r. Alright, so after you're done substitute the h into 2r, just multiply this 2r into 1 over 3 pi r squared, and the last answer you'll get for the volume of this cone is 2 over 3 pi r cubed, which is the same as what the question wants. Alright, so done for the question 1. It's very simple, right? Okay, so for the question number 2, water flows out of the tank at a rate of 15 cm³ per second. How fast is the radius of the surface of the water changing at an instant when the height of the water is 4 cm? So firstly, let's just take out all of the information that we can get above the question from the question. Okay, so here we have volume is equals to 2 over 3 pi r cubed, right? Because this one we just obtained based from the question 1. Okay, so back to the question. Water flows out of the tank at a rate of 15 cm³ per second. So in this one, in this part, you need to be very careful, okay? Because flows out means that the rate is decreasing, so we need to put negative in front of the number. Okay, so how do we know if this is the rate of change in volume or the rate of change in area? So you can just simply look at the units. So based on this question, the unit is cm³ per second, right? Means that the volume is changing over time. Hence, why this one is dV over dt, okay? The volume is changing, the rate of volume is changing per second. So we will have negative 15 cm³ per second. And then, so what does the question exactly want? Okay, so the question, how fast is the radius of the surface of the water changing at an instant when the height of water is 4 cm? Okay, so the question wants you to find the dr over dt. Okay, so based on all of the information that we just obtained at the left, then we will have this relation, which is dr over dt equals to dr per dv multiplied with dv over dt. So when you cancel out this dv and dv, then you'll get dr over dt, which is the same as what the question wants. Okay, so how do we find dr over dv is, we already have the volume, right, which is 2 over 3 pi r cubed. Then we just have to differentiate, then we'll get dv per dr, which is 2 pi r squared. And then the question wants you to the relation that we just create here is dr over dv, right? But however, we have dv over dr, and then we just have to turn it upside down, and then we'll get 1 over 2 pi r squared. And then this r we substitute with 2. So why do we substitute r into 2? It's because based on the question 1, you know that h is equals to 2r, right? And h here, based on this information, height of water is 4 cm, so 4 is equals to 2r, and then we'll get 2 for the radius. Okay, the radius is 2 cm, so we just substitute r into 2, and then we multiply, and then we'll get 1 over 8 pi, I'm sorry. Okay, so the next one, we have to find the dr over dt, okay? And then we just put all the information. Dr per dv is 1 over 8 pi, and then we multiply with negative 15, and then just multiply it, and then we'll get this. Just use your calculator, and then you'll get the answer is as negative 0.5659 cm per second. So that's it.
From this video, we knew how to solve the questions for related rates, and also we knew that quantity change can determine the rate of changes for other changes. This topic is important because there are so many real-life applications related to this topic. For example, is a ladder falling and also a snowball melting. We also know that the method used in this topic is also widely used in the engineering and science. And the last one, we're going to look at the references. This is where we got our question. We got the question from the past year question, March 2013. And that's all from us. Thank you.